In this video, we are going to talk about solving systems of linear inequalities as opposed to equalities. So the same idea applies. It's just basically two or more inequalities with the same variables. Now our solutions, usually there's going to be infinitely many, but a system of linear inequalities are all the ordered pairs that make each inequality true. So our steps. We solve systems of linear inequalities by graphing. So we're going to graph each of the inequalities. We're going to make sure that we consider our dashed or solid line for each one and whether we shade up or shade down. We'll review what those are, but remember, our dashed is going to happen if we don't have an or equal to sign. Solid will happen if we do have an or equal to sign. And if we are solved for y, shading up will be y is greater than, or shading down will be y is less than. Remember to use that up or down. We're following the y-axis, and we have to be solved for y. And then our solution is just simply going to be where the shading overlaps. So we're getting an entire region of solutions, and it'll be infinite. So let's look at our example here. We're going to start by graphing. My first one is already in slope-intercept form here. Because it's just a greater than, it's going to be dashed line. And because it's greater than, I'm going to shade up. So since it's already in slope-intercept form, my y-intercept is 1. So I plot on my y-axis at the 1. And my slope is 1/2. So from that point, I'm going to go up 1 and to the right 2. Or down 1 and to the left 2. Remember, it's a dashed line. And then I'm going to go to my y-axis and I'm going to shade up. So I am shading all of this area here. Okay, let's take a look at our second one. Our second one is in standard form, which we could just simply find our intercepts and go from there, but the shading gets a little more complicated doing that. So let's solve for y. This one's easy to solve anyway. All I have to do is add the x to both sides. I did not multiply or divide by a negative, so I don't need to change my inequality. I'm now in slope-intercept form. I've got the or equal to, so it's going to be a solid line, and it's less than, so it's going to be shaded down. So I'm going to go to my y-intercept of 4. It's on my y-axis. Remember, coefficient of 1, so slope of 1, which means 1/1, so up 1 to the right 1, or down 1 to the left 1. Solid line. Go to your y-axis and you're going to shade down. So that's all of this area. And then when I look for the solutions of the system, it's where they overlap. And it's nice with my highlighter because I can see right in here, this is our solution, or my solution region. So where they're overlapping. We don't have to do any arithmetic unless we're actually asked where do they intersect, which we're not asked to do. Now, the important thing is that we can then pick out solutions. So it says down up below, in the example above, give two ordered pairs that are solutions. So there's infinitely many, but notice what I'm looking for are points that are in this region where they overlap. So for example, I could go to this point right there. They overlap. So that would be 0, 3 would be 1 point. I could also go over here. Let's go right there. So 1, 2, 3, 4, 5. And then up 1, 2, 3, 4, 5, 6. And then 2 points that are not solutions. Well, there's lots of those as well. So I could go right there if I wanted to. I'm just randomly picking anything not in that shaded region. So that would be 0, 1, 2, 3, 4. So -4. Or I could go over here. That's 1, 2, 3, 4, 5, 6. So -6 for my x, +2 for my y. There are literally infinite things we could put for each of those. I just want you to get the idea that inside the shaded region are our solutions, and outside the shading region, they're not solutions.